So we start off with the sine of theta, or secant of theta is 6/5. So I put that one there. And it is our job to find the other 5 trig functions. Okay, so the only one that I guess should be pretty quick, besides the one given to you, would be cosine. As long as you know secant and cosine are reciprocals. The reciprocal of 6/5 is 5/6. So there's one of our 5 answers. But to find the rest, you really need to sketch a triangle and put some of this information in there. So if you know secant is 6/5, you could think of secant as hypotenuse over adjacent, or if you did this step already, you could think of cosine as adjacent over hypotenuse. So that gives you 2 of 3 sides. It doesn't really mean those lengths are 5 and 6, it just means that that's their ratio. But then from Pythagorean theorem, we could figure out what this side is. So we could say leg squared plus leg squared is hypotenuse squared. A squared is 11, and then to undo the square, we do square root, of course. And we would want positive square root of 11 because this is a length. And now we're ready to go. I mean, as long as you know the SOHCAHTOA acronym, we're just pairing up the sides and maybe reducing our fractions a bit. So for sine, I'm going to pair up the opposite to theta over the hypotenuse. Across from it is opposite, hypotenuse is 6. For tangent, I'm going to do opposite over adjacent. Opposite is square root of 11 and adjacent is 5. Cosecant's the reciprocal of sine, so if I flip this over, you wouldn't want to leave your answer like that because that is not rationalized. You would want to multiply the top by the square root of 11 and the bottom by the square root of 11, and the square root of 11 times the square root of 11 would be the square root of 121, but that just turns around and becomes 11. And cotangent's the reciprocal of tangent, so if I was to flip that one over and rationalize, the top gets multiplied by the square root of 11 and the bottom gets square rooted by